Hi friend, welcome back. In this video, we're actually going to do the second part of our code along implementing a math game. My name's Cameron Presley from Small Batch Solutions, so let's get started. Now, in the last video, we had went through a story where my son, Jay, was wanting to work on his math skills a little bit, and I wanted to build him a game. So we did a very small MVP where we would generate a math problem that was just addition, put that in, and it worked. And I actually showed it to my son. He played quite a bit of it, and I was able to get some feedback. So based on that feedback, we are going to build version 2 of this. So what was that feedback? Well, first and foremost, he wanted to keep track of score. I think he played this 3 times before. He was like, yeah, I want to be able to know how many I've gotten right so far. So he wants to be able to keep track of his score. Another thing that he asked for was he wants to also work on subtraction. Now, his addition skills have always been pretty solid. Subtraction, a little bit tougher. So we're going to introduce that type of problem as well. And then for this third piece of feedback, this is actually from me. If you recall, our math problems have been, number plus number. But in real life, that's pretty rare that that's the problems you're solving, right? Usually there's some context, there's some structure around it. So I thought it might be neat to introduce a word problem setup here. Just see what that looks like. So that's what we're going to be building today. Let's get started. Now this first requirement, keep track of score, this is relatively straightforward because we can come down to our main function. We can define a score. So a score of type number, give it 0. And then if they get the answer right, we just say score plus plus. And then that way we've got score. We probably also want to print it to the screen. So we might want to do something like console log score colon comma score. And let's run that and see what we get. npm start. Yep, so we've got our score colon 0 because we haven't gotten anything right yet. We got this 10 plus 1. Let's give it 11. We got it right. Do we want to play again? We go, yep. And we see that our score incremented by 1. Awesome. Let's get this one wrong. Hey, not quite. Correct answer was 10. We'll play again. Say, yep. Score didn't increment. Perfect. Let's get this one right. Let's queue to quit. That's kind of a little bit of weird UI UX because we gave the score, but if you do get it right, we never really show you the updated score. So let's fix that. We're just going to come down here and say console log, something like final score, whatever score is. Let's try that again, see if that's any better. 19, let's play it again, 4, 9, let's get this one wrong, let's say it's 11. Let's hit Q to quit. And we get a final score of 3, which lines up with what I'd expect to see. So that's already a little bit better. So one thing that is kind of noodling around upstairs is that before we did score, before we put the score into the game was pretty much stateless, right? Because we were always generating a new problem, something would happen, and then we would just generate a new problem. Really, the only state we had going around was whether we should continue playing or not. And yes, it's state, but essentially if that ever turned, that's really just a way for us to keep track of if we should keep looping the game. Once we add score, though, now we do have state, right? Because it's all, when the game starts at 0, but depending on choices the player makes, the score will change. I don't have a problem with score being a variable like this right now, but if we start having more state, then I'm not going to like how this code's going to start shaping up, because now my UI code is going to have to start maintaining state. Like I said, for right now, I think it's okay, but my spidey sense is tingling here a little bit of like, I wonder if that's something that we're going to need to refactor later. But I'm not going to refactor something now if it's not needed, right? That's wasted time, wasted effort. So I'm going to leave it alone, even though my experience and gut's telling me I may need to tweak that. So we've solved keeping track of score. Awesome. Now let's do the new type of problem, subtraction. Well, the good news is if we take a look, we have this create function that creates us a problem. So we can go into create. And as a reminder, our problem is a type that has two numbers, first and second, and our create just gives us some valid numbers between 0 and 10. And then we know how to calculate an answer. It's always first plus second. So right off the bat, we're going to need to tweak a few things. First and foremost, the fact that a problem has a first and second isn't enough information. We actually need to know what type of problem it is. So let's do that. Now, one thing we can do is we can actually create a union type for this. So we can say type, problem type. So it's either going to be an add problem or a subtraction problem. And now down here, we can say that problem has a type of type problem type. Save that. We've got a little bit of a compilation error here because now our create function wants to give us some type. So we say, cool. Since we only did additions before, that's what's got to be. Save the file format. And if we were to run the code, this should all still work. Nothing crazy. Yeah, so we're still getting additions. So far, so good. So I'm going to go ahead and kill the app there. So this works, but we now need to be able to create both addition problems and subtraction problems. So one thing we could do, kind of thinking about this aloud, is we could do something like type equals, and we can randomly generate a type because we have this choose item thing. So we can say choose item. And I'm going to give a specific type to help the IntelliSense out a little bit. So we're going to say, I want you to choose an item from problem type. And you've got add and you've got subtract. And if we hover over type, you'll say that's of type problem type or undefined, but if for some reason it's undefined, cool, it's an addition problem. And say, oh, type there. So when we create a problem, you choose either add or subtract. Let's see what that gets. Now, the issue we're going to run into is we've updated the type, but when we go run this, we're still going to get addition problems, right? Because we're not really doing anything with that type, right? So we've got an 8, right? 14 or 13 in this case, so on and so forth. So let's just console log for right now what this type is, just to see, are we actually getting what we expect here? So I'm just going to say type. Let's run this app again. So we got an add there, so we do 16, add again. So we'll go again. I'm just going to keep getting to see if we can get a different one. And there's subtraction. So, right, but we can do 9 and it works. So we're generating types of add and subtract, which means if we want to show it right, we got to go back into our UI in the index, and this has to change. Now, what we could do to make this work is we can do a switch on p.type, do some cases here, and we could say console log, pretty much just grab all of that. And then we do a break. Otherwise, it's this. Break and get rid of that. And let's run this app again. 0 minus 1, that'd be -1, but that's not going to work because we don't have the answer being calculated correctly yet. But we are at least getting some values here, right? Let's see if we can get an actual plus here. Saved. There we go. Cool. So that works, but I'm going to let you on a little secret. I kind of hate this solution. And the reason being is that now I've got my business rules shoved into the UI. I don't like that. And you might be thinking, but Cameron, you don't really have business rules. Well, we do. This, right? We've got our decision logic based on whether it's an add or subtract, how to format it. So I don't want that to be in here. I'd much rather this be a function in problem. So let's do that. I'm going to come in here and I'm going to say export function. We're going to call this format. And it's going to take in a type problem. And it's going to turn back a string. I'm pretty much going to grab this entire switch statement, plop it in here, and instead of these console logs, we can just straight up do a return, get rid of the breaks, right? Because we don't need that since we're bailing out the switch statement, format it. And the nice thing about taking the business rules and shoving in problem, this is pretty easy to unit test, right? It would have been really hard to have tested it while it was inside index, but now it's pretty trivial. And we can just use this function. So back in index, we can create the problem, and then we can say console log format, make sure we grab the one from problem, and then pass in our problem, which is P, save the file. Now let's start this. Yep, and it looks like it's working so far. Remember, we're calculating the answer incorrectly still, so we're going to just, yeah, so we're getting some pluses, some minuses. Great. Cool. So that's already better. And now our UI doesn't have business logic. It just essentially says, cool, we're going to log a score, create a problem, log the problem, so on and so forth. So that's already better. Now we got to update our answer function, because you saw that it's always assuming addition, and that's not true. So kind of same trick as before. We're going to say switch on the problem type. If it's an add, we can essentially do this. Otherwise, it'll be p first minus p second. All right. Let's run the app again, because that should get us pretty darn close to what we're looking for. 4 minus 9, it should be -5. It is, great. 9 plus 3 is 12. Let's get another one, 15. That should be -1, 0, 3, and let's say -3 here, because that should be wrong. All right, and we get -2. So cool. We're in a pretty good spot for how this is working, but there's a small problem. Subtraction works, but this is the issue. Remember, my son is in first grade. So I don't know about you, but I don't know how many first graders actually know how to work with negative numbers, right? That's not a concept that's taught. But if we take a look at how we're generating our problem, how we're creating it, we're just getting first and second. So this isn't going to quite work. We've got to essentially force that the first number is always bigger than the second number. So let's make that work. So what we're going to do is we're going to update our function and say we've got this numbers array that's going to be generate valid number followed by another generate valid number. So we've got two numbers. Our highest number is going to be wherever the math.max of numbers is. We need to spread that, I believe. Cool. And same thing for lowest, except it'll be math.min. So this will give us the highest and lowest number, and then we can update our definition to say, well, this is always the highest, and this is the lowest. Put our commas in, save the file, and that should actually fix the problem. So let's kill this app, run it again. Bingo, right? We've got 10 minus 5, so we get 5. 10 minus 1 is 9. Get 13. 9 minus 1 is 8. Yeah, so that seems to be working pretty well. But there's another problem. When we're generating the problem now, we're always putting the highest number as the first operator, even if it doesn't matter. Because if it's addition, I'm okay with it being 0 plus 2. That's fine. Because in addition, it's commutative. It doesn't matter which way you add it. Subtraction, though, isn't, and that's the problem. And so I don't really like this solution because now I'm always forcing the highest number to be the first one to be printed, and for addition, that's not always needed or true. Right, so let's see if we can get that to happen, right? Like, law of subtractions. Yeah, like it's 7 plus 2. That's fine. We can get 9, but 2 plus 7 is also a valid output, and we're never going to get that given how this is written. So essentially what's happened is we've got some different decision logics going on here, right? We would really want to do something like this where we've still got our numbers, and then we're going to say if type is equal to subtract, we would want to do something like first is math.max of whatever numbers is. The second is whatever math.min is of numbers. And then the type is of type, nothing crazy there. Otherwise, we'd want to get rid of this bit. And then here, we essentially would just say, plop that in here. Instead of highest, this is just going to be numbers of 0. This is going to be numbers of 1. And we can put exclamation marks to tell TypeScript, like, yeah, we know it's going to be a thing. Let's see here. I've got a, oh, do I have too many braces? Oh, don't have enough. So let's put this in here, save the file, which will format. Cool. That should solve the problem. Let's take a look. That's 8. 8. Let's get one where it's flipping around. Yeah, so can we get one where the lower is... That's funny that we're always getting... There we go. So 5 plus 8, right? We wouldn't have gotten that before. So this works, but I kind of hate it. I don't like this because we've got some decision logic based on type. We've got to do like this unsafe, like unboxing thing. I'm just not a fan. So here's what I'd rather do. I would like to use a little bit of what we would call a strategy pattern here, or a factory pattern, where based on the type, I call a function that will do all of this. So let's do that. So I'm going to come down here and we're going to create a new function. And we're going to call this create add problem. And it's going to take in two numbers, A and B, right? And it's going to return back a problem. And we can literally, in this case, just say return. First, it's going to be A. Second is going to be B. And then the type is addition. So instead of doing this bit here, we can get rid of that. And we can literally just say return, create add problem, generate valid number, generate valid number, and that'll work. And for the subtract, let's do a similar thing. So we're going to export a function here called create subtract problem. Takes in two numbers as well, right? Because we need those for the type. But now we can have our decision logic. So we can essentially say const highest equals whatever the max is of A and B. And our lowest is whatever the minimum of A and B. And we can return first will be the highest, second will be the lowest, and then our type is going to be that subtract. That works. We can come in here and we can essentially say return create subtract problem. And same thing, generate valid number, generate valid number. Now we don't need numbers anymore. And notice how we also got rid of the null coalescing thing. So that's kind of cool. Right, because we was doing the question mark period thing, or sorry, the exclamation point to get numbers out of the array. That works. If we wanted to like reduce the generate valid number calls, I don't think it really matters, but let's say we wanted to. So we could say const A equals generate valid number, const B equals generate valid number. And if you're wondering why I'm calling them A and B, is because these are essentially placeholder variables. We're not doing anything fancy with them. So I can say A comma B here, A comma B, save. And we can run this. So if we do npm start, there's our 7. Yep, and the addition's already working correctly, right? Cool. And let's quit. So that works. But here's something else that's kind of cool, right? These two functions take in the same inputs. And right, and they're always the same inputs, right? They're going to take in whatever A or B is. So we could actually do decision logic to figure out which function to call instead. So we could say const creator. No clue if that's how that's supposed to be spelled, but we'll figure that out in a minute. Should be OR. We can say if type is equal to subtract, we want the create subtract problem function. Otherwise, we want the create add problem function. And then we can just say return creator, if I can spell correctly, A of B, and that gets rid of all of this. Right, so one of the benefits is that we are essentially setting up our inputs here, right? The type, the A and the B. We then say, all right, what's our creator function? And let's rename this a little bit. So we can say this is our creator func. That says, well, if it's subtract, it's a subtraction problem function. Otherwise, it's the create add function. And then we just invoke it. That's not too bad. This also reads a little bit cleaner. And if we wanted to add, let's say, a multiplication problem or a division problem, we just update the logic here. For those with an OO background, this may look exactly like a factory pattern or a strategy pattern. In functional programming, this is just passing funcs around. That's all we're doing. Nothing crazy. But yeah, that will absolutely work. And let's just run the app, make sure everything is still working, but it should be. This one's 10, 2 minus 0 is 2. Let's get this one wrong. Yeah. Let's get that one correct, and let's get this one correct as well. And that's quit. Awesome. So yeah, that actually works out really well. And if we take a look at our functions, super easy unit test, very easy to unit test, right? Because we are controlling all the inputs here. So these are pure functions. This one would be a little bit trickier to test, just mostly because we have to we have to mock out what choose item would return back, and then generate valid number. We could do that, but honestly, there's not a ton of value doing that, so not a big deal. Like if we wanted to unit test this, we could, but I don't think you're going to get a ton of value out of that, because really the thing that you cared about is, did you call the right function here? Create, subtract, or create, add. So if I were to write a test on this, it would probably be like, hey, call the create function, override what choose item does so I can force it to return back add or subtract. And then I would essentially make sure, did I get a problem back that was of type add and or a problem type of subtract? Because I've already going to have tests to make sure that those problem types were set up correctly. Probably the way I would do it. All right then. So let's go back to our index, because I would argue we've absolutely knocked out create new type of problem. Now introducing the word problem. Okay, so we've already got a format function here, so this is going to actually be pretty easy. The only thing we've got to do differently is just return what's the string for first and second. So let's work on add. Now, one of the things that my son loves is he loves candy, and his favorite candy is gumballs. So let's put in a word problem like that. Something like, and this is going to be, yeah, we're going to say Jay has first gumballs, if I can spell correctly, and then gets P dot second more. How many does he have now? So let's comment this out return, and let's go ahead and run this app, see what we get. I'll say 0. There we go. Jay has 7 gumballs and then gets 3 more. How many does he have now? Let's say he's got 10. Yep. So we play again. He has 8 and then gets 0 more. How many does he have now? Let's get this one wrong. Let's say he's got 4. That seems to work out like a top. So cool. That's already a little bit of a word problem. And then for subtraction, the other thing that my son really enjoys is he loves video games, and one of his favorite video games is Kirby and the Forgotten Land for the Switch. Fantastic game. Can't recommend it highly enough. So let's actually do one based on game time. So we might say something like, Jay has minutes to play Kirby. He's already played minutes. So he's already played so many minutes of it. How many minutes does he have left? A little bit wordy for sure, but let's see what that looks like. Coming out the extra return. Let's run the app again, see what we get. Yeah, 9 minutes to play. He's already played 5, so that'd be 4 minutes left. Perfect. He gets 8 and 8, 16. Gets 1 more. Apparently my son's going to get a lot of gumballs. There we go. 7 minutes to play Kirby. He's already played 0 minutes. How many minutes does he have left? He's got 7 minutes. Perfect. That's already worked out really well. And there we go. And let's say that these word problems were a little bit more complicated. We could actually do the same trick here where we could say, where we had create add problem, create subtract problem. We could have a format add problem and a format subtraction problem if we wanted to break it out. But honestly, this is straightforward enough. This is also a pure function, right? Because it's literally just based on the type. You could easily unit test this. Not a big deal. Yeah, I think that knocks out the third requirement. And so for this iteration, And I think that's going to wrap it up. I'm actually pretty excited with how this has evolved over time, right? Because we went from a very simple, let's just do like, A plus B to we've got a word problem format now. We've also got a score we're keeping track of, and we introduced a brand new problem type. And we've even found that even in such a simple problem domain, basic mathematics, that we can get some interesting business rules, requirements, if you will, of, the first number's always got to be greater than the second number. So I'm really curious to get this in front of my son, Jay, and see what he thinks, right? Is there anything else that he'd want to tweak, anything else he would want to see? I don't know. So I'll keep you all informed. Do me a favor. If you've gotten to this part of the video, drop a comment, right? Let me know, what are you liking about this format? What are you not liking? Because it's something new, right? And without your all's feedback, I'm going to keep doing this the way I think is right. But if there's something you want to see me tweak, love to tweak it. With all that being said, thank you all so much for the time. Cameron Presley from Small Batch Solutions, and I'll catch you in the next one.